we want us to talk about a number of basic properties of angles involved in polygons. Then apart from that, I'll also highlight how to find the sum of interior angles of a polygon, how to find an exterior angle of a polygon, as we go on and on. Therefore, we will follow through. The first thing that we do, we will list polygons, examples of polygons. Let me say examples of common polygons. So we have the normal one that we talk about is a pentagon. A pentagon, it has what we call n is equal to 5. We have a hexagon. Hexagon, n is equal to 6. We have what we call a heptagon. A heptagon, n is equal to 7. We have an octagon. An octagon, n is equal to 8 sides. Then we have a nonagon, whereby we are saying that here n is equal to 9 sides, and we have a decagon. Here whereby we are saying n is equal to 10. So for this, you've got to know the name and the number of sides of each. Then here, normally in polygons, n represents sides of the polygon. N represents sides of the polygon. Then apart from that, we also have to know what is the formula of finding the number of sides of a given polygon. Number of sides of a polygon. Number of sides of a polygon is equal to 360 degrees. I divide this by one exterior angle. I divide this by one exterior angle. Therefore, if I am finding the number of sides of a polygon, then the formula is 360 out of, or I divide it by one exterior angle. Then one exterior angle of a polygon is given by one exterior angle of a polygon is given by 360 divided by n. What is n? Sides of a polygon. One exterior angle. Meaning, if I have one exterior, if I'm looking for one exterior angle, then the formula is 360 degrees. I divide it by number of sides of the polygon. From there, another formula that you need to take note of as you look at polygons is the formula that you're talking about, sum of interior angles of a polygon. Sum of interior angles of a polygon. Sum of interior angles of a polygon is given by 180 degrees into bracket n subtract 2. Or the same formula can as well be written as what? As 90 degrees into bracket 2n subtract 4. So it is either I am using this formula or this one to find the sum of interior angles of a polygon. And when I talk about the sum of interior angles of a polygon, I'll try to draw here a pentagon so that we see what we are trying to say. Just a sketch of a pentagon. So that is our pentagon. So a pentagon, here n is equal to 5. When I talk about the interior angles, then I'm talking about this angle, this angle, this angle, this angle, and this angle. So the interior angles of a polygon, that's how they look. Interior angles. Yeah. Interior angles. While if I try to stretch or to extend this particular line like this, then here I'll have an angle that I'm calling exterior angle. It is on the outside. Exterior angle of a polygon. So this angle here, this one is exterior angle of a polygon, while this angle here is interior angle of a polygon. So if I am talking about finding the interior angles, then it is this angle, this one, this one, this one, and finally this one. So those are the 5 interior angles of a polygon. And I've said that then either the formula is this one, you use 180 degrees into n minus 2, or you can as well use 90 degrees into 2n minus 2. All those formulas will lead you to finding what? The sum of interior angles of a polygon. An exterior angle, then it will always be on the outside, the exterior angle. But then there is something that you also ought to realize here, that the sum of an exterior angle and the sum of an interior angle of a polygon must add up to 180 degrees. Why? They are angles on a straight line. Therefore, another basic aspect that you have to know about polygons, apart from what we talked about, before we can go ahead and look at some examples, I am saying that one exterior angle plus one interior angle, we are saying that this must add up to 180 degrees. What is the reason? They are angles on a straight line. They are angles on a straight line, and therefore they add up to 180 degrees. An example. Find the sum of interior angles of a polygon. Find the sum of interior angles of a polygon. What are we saying? That we know that sum of interior, this sign represents angles, is equal to 180 degrees into n minus 2. And then when you look at this, we are saying 180 degrees into bracket n, a pentagon. Find the sum of interior angles of a pentagon. Find the sum of interior angles of a pentagon. So a pentagon has 5 sides, then I'll say 5, take away 2. So from there, I believe you are able to follow through these formulas. They are very important formulas when you're revising polygons. I'll come here. Then now we follow this and say sum of interior angles of a pentagon is equal to 180 degrees into 5 take away 2. So n is representing the number of sides. For a pentagon it has 5. Therefore I have 180 degrees multiplied by 5 take away 2 is 3. So 3 times 180, I have 0, I have 4 carry 2, 540 degrees. So that is how you find the sum. But then also someone will give you sum of interior angles of a polygon, and then he will ask you to find the number of sides. I can use this as an example and say example 2 over the same. It might look like this. Now we have to calculate it the reverse way. That find the number of sides of a regular polygon with a sum of interior angles of 540 degrees. So here now we are being asked to find the number of sides of a regular polygon with a sum of interior angles of 540 degrees. So what do we know? The first thing that you have to know, looking at this example 2, comparing it with example 1, you will realize that now this one you have been given the sum of interior angles. You are being asked to find the number of sides. But in example 1, we had the number of sides by the fact that we know the name of the polygon is a pentagon, and therefore here n was equal to 5. So here we don't have the number of sides, but we have the sum. So what do? We write the formula down and say, but the formula of finding sum of interior angles is sum of interior angles is 180 degrees into n take away 2. Then can you substitute? What is the sum of interior angle of the polygon? 540 degrees is equal to 180 degrees into n minus 2. So now we have to play with these particular values to find the value of n. Therefore, the first thing you do, you remove the parentheses. Then now you say, I have 180 n minus this 180 multiplied by 2 is 360 degrees. Now I want to move this to more space here. Okay, now I'll say I have 540 is equal to 180 n take away 360 degrees. So I have to collect like terms on one side, therefore I'll say 540 plus 360 degrees is equal to 180 n minus 360 degrees plus 360 degrees, so that I'm able to do away with this. Now what do I have? I add this side and have 0, 0 again, I carry 1, I can see 8, 900 degrees is equal to 180 degrees n. So I'm looking for the value of n. Therefore I divide both sides by 180 to find the value of n. So this and this, degrees and degrees, 0 and 0. So n is equal to 18 into itself is 1, 18 into 90 is 5. So n is equal to 5 sides. I hope you are following through. That you simply substitute in, then because you are looking for the value of n, collect all the numbers on one side, then remain with the variable n on one side. Because you are looking for that, then you divide through the entire equation with 180 degrees to be able to find what? The number of sides of a polygon that has a sum of interior angles of 540 to be equivalent to what? N is equal to 5 sides. Now, I want us to look at another example whereby, for instance, we have been given exterior angle and you are being asked to find the number of sides. Example 3 will look like this. Given that a polygon has an exterior angle of 40 degrees, fully stop, find a number of sides. Is the first question. Number of sides. Question B. Sum of interior angles of the polygon. Sum of interior angles of the polygon. Sum of interior angles of the polygon. So this is our question. Given that a polygon has an exterior angle of 40 degrees, find question A, number of sides. What do we know? We know that n, which is representing the number of sides, is given by, we know that n is equal to 360 degrees out of exterior angle. That is the formula to finding the value of n. But then we have the exterior angle, we have 360 we are looking for n. Therefore, n will be equal to 360 degrees out of 40 degrees. So the degrees and the degrees, 0 and 0. 4 here, 1, 4 here, 9. Therefore here, number of sides is what? 9 sides. We said a polygon with 9 sides is called what? A nonagon. It is called a nonagon. Now we have the number of sides. We move here, sum of interior angles. We know that sum of interior angle is given by 180 degrees into n minus 2. So 180 degrees, what is our n? 9. You found it above there. Subtract 2 from it and then you find the product. Therefore, the sum of interior angles is 180 degrees multiplied by 7. 9 take away 2 is 7. So what is the sum? 7 times 0, 0. 7 times 8, 56, carry 5. 7 times 1 is 7. 7 plus 5, 12. So the sum of interior angles of the above polygon is 1260 degrees. So that is how you can move from this one exterior angle to finding the number of sides as being 9. After you found the number of sides being 9 sides, then you move ahead and find what? The sum of interior angles of the triangle by using the formula 180 degrees into n minus 2. So you see, whether you have the number of sides, you can go ahead and find what? Find the sum of interior angles of a triangle. If not, you can also start from the aspect that you have exterior angle. The exterior angle assists you to find what? The number of sides. Once you have the number of sides, then that will assist you to find the sum of interior angles of a triangle. I hope that topic will help you to revise through the topic of what you're calling polygons as you move on. But then also one thing that I want us to look at is how to find the area of a regular polygon as I wind up on this particular topic of polygon, because it's a very essential topic in our curriculum at school. So I want us to go through on how can we be able to find the area of a regular polygon. So you follow through and see. Hope that is clear. So area of regular polygon. Area of regular polygon. Area of regular polygon. So what do we know? That a regular polygon, we first of all need to know what is a regular polygon. What is a regular polygon? Here we are saying it is a polygon whose all sides are equal in length. Are equal in length, or the measurements of all the sides of a polygon are equal. For example, if I draw a pentagon here, so I'm just trying to sketch up a pentagon, you to look through and see. So if this is my pentagon and it is regular, the length of this side is equal to the length of this side, equal to the length of this side, equal to the length of this side, equal to then we say this is a regular polygon. This is a regular polygon. Why? The length of all the 5 sides are equal. But then also as you look at this, there is one thing that I want you to know. That for a regular polygon, then it is the number of sides of the polygon is equal to the number of triangles that are formed inside that particular polygon. Good. I hope you take note of that. I hope you take note of that. So I want to clean this question. So there is one thing that I've told you that I want you to take note of. NB, what I'm calling NB, that number of sides of a regular polygon is equal to the number of triangles is equal to the number of triangles formed in the polygon. So for instance, if I was to try and sketch a pentagon like that, for instance, if I was to try and sketch a pentagon like that, so this is the center of the pentagon, then I want to try and be able to come up with the number of triangles inside that particular pentagon. So this is how I'll be able to form the number of triangles. This is the first one. This is the second one. This is the third one. This is the fourth one. So 1, 2, 3, 4, and finally 5. That if n is equal to 5, so also we have what? 5 triangles formed inside that particular triangle. So if the number of sides of a regular polygon is 5, therefore we are saying that also we have how many? 5 triangles are formed inside that particular triangle. I want us to look at an example and see how can we be able to find area. Example, area of a regular polygon. Example, calculate the area of the regular polygon below. Of the regular polygon below. Then I want to come and draw this polygon, you see. Let me assume I'm still drawing a pentagon. So that now from here, I want to assume this is my center. So this length here, I'll say is 8 centimeters. This one here is 6 centimeters. So this is my center. The first thing that you do, try to divide that particular polygon into a number of triangles and see how many are there. The first one, the second triangle, the third triangle, then the fifth, the fourth, and the fifth triangle. So I have 1 triangle, 2, 3, 4, and finally 5. What happens? If I look at this, and this is a regular polygon, so this line here is perpendicular. Therefore it forms what? A right angle triangle. Now with this right angle triangle that I have here, then it simply means that for me to find the total area of this regular polygon, I find the area of 1 triangle, then I multiply by the number of triangles formed inside this particular polygon. How many are they? They are 5. Therefore, we will come here and say, so we will come here and now delete this, and we'll go on to look at another one and see. Therefore, now we are saying total area of regular polygon is given by area of 1 triangle, this one here, multiplied by number of triangles. Number of triangles in the polygon. So these are very important formula that we need to know. And I've said this one is only applying for regular polygon. Total area of regular polygon is equals to area of 1 triangle times number of triangles in the polygon. So with this, then we go ahead and find the area of that particular polygon. So we shall now come here and say, because we have this space here, now you can use this space. Now area of one of the triangle here it will be, because it's a right angle triangle, area of triangle is equal to a half base times height. Therefore a half multiplied by the base, which is 8, times 6, this is 1. So here 1, here 3. What is the area? 24 centimeter square. That is area of 1. So total area of the polygon, total area is equal to 24 square centimeters, multiply this by 300 and by 5, because we have 5 triangles. So 5 times 4 is 20, carry 2. 5 times 2 is 10. 10 plus 2, 12. Therefore, the total area of that particular triangle is what? 120 centimeter square. So I hope you follow through this, and I hope that helps you to revise for your polygons, which is a very, very important topic in your day-to-day learning as a student. Thank you so much.